So let's take x cube minus x, and if you take x square, x common, x square minus 1, then x into x plus 1 into x minus 2, x minus 1. You take, like this we take, right? Minus 1, 0, 1. You remember this one? Wavy curve method.
Yes, sir.
And 1. Take more than 1, you take 2, 3, 4. Positive, positive, positive. It's positive. Sir, no. Less than 1, but greater than 0. Greater than 0 means what will happen? Less than 1, this is negative. But greater than 0, between this is negative. Yes or no? But this is
Yes, sir. Yeah, that is
positive. So therefore, this is negative. That's the reason I drew down, right? I drew, okay, below the x-axis.
Yes, sir.
Then automatically this is positive, positive. Why? Because this is greater than minus 1, some negative off. If you keep negative off, this is positive, this is negative, this is negative. Negative, negative, all are positive. So this is positive. Understand? So then downward, then less than, so the negative, negative, negative. This is negative. Yes or no? Less than minus 1, but we have here minus 1. So therefore, minus 1 to 0, you see it is positive. Now understand? That is the reason. Then if it is positive, you should write as it is. Modulus x, you should write as it is. If it is,
if it's negative, then
put one more negative sign.
minus. Yes,
And
sir.
if it is positive, write as it is. That is the reason we are taking these intervals. Minus 1 to 0, 0 to 1, 1 to 2. Yes or no?
Yes, sir.
Now then, such a simple thing. Again, you should not forget why we are changing.
Yes, sir.
Why we are writing the 3 intervals? Why we are writing? Because there's sign change in this 3.
Sign change. Yes, sir.
Wavy curve method. Yes or no?
Yes, sir.
Okay, did you learn all these properties, even function, odd function, these properties are clear?
Yes, sir.
Okay, then again I'm going forward. Okay. So miscellaneous is very, very important part of this miscellaneous is, so 30, everything is important. So first question, so many times we discuss that we have to take x power 4 out, then becomes x. Understand? Like this.
Yes, sir.
So like this, x power 4, if you take out, this becomes x, and x by x power 5 is x power 4, and this is 1 minus x by x power 4 is 1 by x cube. If you take numerator as t, 1 by x power 4 becomes dt. 1 by x cube is t, then minus 3 by x power 4 is dx is dt. Like that. That is the reason. So next question. Yeah, next question, this one. How do you do?
So a by this, you can't divide the terms. So we divide.
Yes, we have to divide.
Yes, sir. So first we divide and then we write it.
This is improper fraction, raise power 4.
Yes, sir. So we divide.
So divide, but yeah, you have to divide, but we can also do something. X power 4 minus 1 plus 1 we can do also. Understand?
Yes, so then we can write as a square
Plus 1
minus b square.
Yeah, exactly.
That formula.
So that
Yes,
is
sir.
good number. You can divide also, but if you have to divide, then you have
So
to.
this is easier only. Yes, sir.
So x power 4 by x minus 1 into x square plus 1 divided by 1 by this thing again. 1 by x minus 1 into x square plus 1. But you know what? And this part fractions you have to do anyways. So here x power 4 minus 1 is x minus 1 into x plus 1. Okay, x minus 1 gets cancelled.
X plus 1 by x square plus 1.
X square plus 1 also gets cancelled. So only x plus 1 will be there. That is here. Again, this is here. So this directly we reach this term.
Yes, sir.
Then again, this one, no, anyway, this one is partial fractions. You must do this.
Partial. Yes, sir. A by x minus 1 plus bx plus c plus x square plus 1.
Yes. So once you go through that and see how you get.
Yes, sir.
This is very, very important question. Question number 40.
Yes, sir.
Number 40. Log of log x plus 1 by log x whole square. Generally, log x, how do you integrate? Take 1.
Yes, sir. Then UV rule.
Apply UV rule.
Mm.
Actually, there is a shortcut for this, so I'm just thinking about some other alternate than this. Of course, if you do like this, then you get 1 by log x whole square. Then it gets cancelled actually. Okay. Log x I'm taking as some t.
Yes, sir.
X equal to e power t. Nothing is there.
Yes, sir.
Dx equal to e power t dt. Is that okay?
Yes, sir.
So then this becomes what? Integration. So dx log x is t. So log x is t, log t. Log t plus this is 1 by t square
By T square. Yes, sir.
into
Dx by e to the power t.
okay.
Yes, sir. Sorry. Yes.
See now log t. What is integration? What is the differentiation of log t?
Sir, one
Differentiation of log t.
1 by t. Sorry.
1 by t. Good. What
I
is
thought you asked about integral, so I
yeah.
got confused.
So what I will do is see e power t I have e power t f of x. So log t plus, so what I do is log t ka 1 by t, minus 1 by t, I'll add plus 1 by t, plus 1 by t square. This is what I did. This
Yes, sir.
is if I
So
take
this is f
f
of x
of t.
plus f dash of x. So we get
This is
et
f dash
into
of
f
t.
t.
Because I add minus 1 by t and add plus 1 by t.
Yes, sir.
So then automatically what do I get is e power t into log t minus 1 by t. Let's see. Now e power t, x log of log x minus 1 by log x. This is very, very important trick. From here you see, this is very important question. Understand this very important model. Sometimes question will be given from here. They give this much only. E power t into log t plus 1 by t square. You have to add minus 1 by t plus 1. Very important. Consider this very, very important model.
Yes, sir. Yes, sir.
But what he did here, you can also observe what he did. What is that he did? So he has taken first function and he integrated the first function. You understand? This is what he integrated the first function. He did not touch the second function. Second function he did not do at all. Sir, no. This is second function he kept.
Yes, sir.
Second function kept as it is. Because once you differentiate, now this one is done. Sorry. If you integrate again, then you are going to get this term. And automatically that gets cancelled. That's the idea there. Okay, now we integrate this.
Yes, sir.
If you integrate this one, now you should take 1 by x into 1. So this is how you get.
Yes, sir.
This one only did. So this is what you get, right?
Mm.
So you get that. And this part gets cancelled. You see. X log in x log of log x minus x by log x. That's what we got now also.
Yes, sir.
Another way. This is another way.
Yes, sir. So, but this method is only easier.
That method is easier, but this also should answer.
Yes, sir. Yes, sir.
Chalo 41. Root cot x plus root tan x. Very, 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 very important. These are all important questions. Miscellaneous
So, all
example
the miscellaneous examples.
and miscellaneous exercise. So now each and every question you should learn thoroughly well. These questions will definitely come. Okay, chalo.
Yes, sir.
X plus root tan x, how do you do?
So we take tan x is t or cot x is t. Maybe. Tan x is equal.
Root tan x is t.
Okay. So we take tan x is equal to t square to make it easier.
Yeah. Yeah, take. It's completely different model, completely different model. We'll discuss. It's there, solution is there, but we'll discuss in a simple way. Oh, but I'll do in another way actually. Here one way is I'll do in another way, So
Yes, sir.
root of cos x by root of sin x.
Hmm.
Root of sin x by root of cos. What you get is here cos x plus sin x. By root
Yes,
sin x into cos.
cos.
Again, once again, this we are done. Yes or no? This model I told you how to do it. What is that you should do? It's cos x plus sin x is there. Sin x minus cos x you can take as sin x minus cos x you can take as t, so that this becomes dt. You see, such a simple.
Yes, sir.
Cos x plus sin x is dx is dt.
Yes, sir.
And then square on both sides. See, 1 minus 2 sin x cos x. A square plus b square is 1 minus 2ab is this. Plus 2ab is t square, Yes or no?
Yes, sir.
1 minus t square is 2 sin x cos x. Yes or no?
Yes, sir.
This is, if you take this dt, then this is going to be 1 minus t square the root by 2.
Yes, sir.
Kevala root 2 into this is, sin inverse t. 1 by root of 1 minus x square is sin inverse x.
Yes, sir.
Got it?
Root 2 into sine
1
inverse t.
minus
Yes,
t
sir.
squared by 2. By 2 I wrote up.
Up. Yes, sir.
Root 2 into sine inverse t is this. Sine inverse of t is sin x minus cos x. This is your answer.
Yes, sir.
But if you want, what you can do is, you can also do this. Root 2 into sine inverse of, here you can multiply and divide with root 2, root 2 if I multiply, then also divide. So this is, what happens, this is sine of 1 by root 2, 1 by root 2, sine x is
Yes, sir.
Sine x cos pi by 4. So sine of x minus pi by 4. Get this also.
Yes, sir.
Yeah, this is what is your answer. If you want, you can simplify and write like this. There's no problem. Got
Yes, sir. Yes, sir. Got it.
I multiply and divide with root 2. Sin a cos 45. Cos a sin 45. 1 by root 2.
Yes, sir.
Sin of x minus pi by 4. Okay, got it?
Yes, sir. Got it.
Would like to write or?
Then I just took a screenshot, but if you give me time, I'll write.
Okay, screenshot. How did you take a screenshot in laptop?
So yes, sir.
How do you take laptop?
So Windows and print screen.
Oh, Windows and print screen.
Windows FN and print screen.
Windows, where is Windows?
So the one beside that says FN, no?
F?
That and FN.
FN. Oh, print screen is here and F10 is.
Yes, the print screen is on top, Windows, and then the one to the left of Windows, the symbol. So otherwise it might work with Windows print screen also. You can try that also.
Windows F8, huh? F8 is Windows, huh?
No, sir. The Windows logo is there, no? In the last row, beside the space bar.
Ah, right. Gosh. So Windows press screenshot, huh?
Yes, screenshot or print screen.
Print screen.
That should.
That's what. Okay, Windows please. Yeah, yes. Yeah, correct.
Yes, that will get saved in the files, the file explorer.
That's nice. Now I got it. I was just looking for that actually.
So this laptop, for a very long time after I got a new one in February or something, and this one, it didn't work that way. For this, I have to press FN also along with it. So, yeah.
All right, so, okay, we have taken screenshots, all right, but this,
yes.
You see the same idea. If at all you have 2 sin x cos x or sin 2x and numerator is cos x plus sin x or cos x minus sin x, whatever. Understand? Sin x plus cos x,
Yes, sir.
both are okay. Okay? So,
yes, sir.
that, of course, the answers will differ a little bit. You got.
But that answer is also right only, no? So
obviously, that time is the same only, na. See that little. So what did you get is, see, what did you get is root 2 you got. Yes or no? If you root 2 you got outside, right? And that is sine inverse. You got sine inverse of sine x minus cos. Yes or no? You got this. Yes or no?
yes, sir, we got root 2
You
sine
have to
inverse.
change to tan inverse. Let's say you have to change to tan inverse.
Tan.
Take root 2 into sine inverse of, I'll take sin x common. I'll take sin x common.
Sin x into 1 by cos x minus cos x by sin x. So 1 minus cot x.
Okay, just a minute. Okay, I have to change to tan inverse. Okay? Let's say
Yes, sir.
tan inverse. Okay. No problem. What is there? So now this is sine inverse of this way. This is what sine inverse means. What this is sine x minus cos x, and this is 1. No, this is 1.
Yes, opposite by hypotenuse.
This is going to be under root of this is 1 square minus this square.
This.
That means what? 1 plus 2 sine x cos x.
Yes, sir.
Yes or no? This square
Yes, sir.
minus this square. Minus this square means what?
Sin square x plus cos square x minus
Plus
2 sin x
sin
plus x. Sorry, 2 plus.
Okay. Now I have to change to tan inverse. Root 2 into tan inverse of. You know what tan inverse of? This thing. Sin x minus cos
Sin
x.
x minus cos x by root over 2 sin x cos x.
This is, yeah. Root 2 into, got it, yes, sir. Got it.
Yes, sir, got it.
Now sin x you take common. You take sin x common. Or you take sin x, tan x, no, divide by the cos x, divide by cos x.
Yes, so divide by cos x, we get the
Minus
answer.
1 by here also. If you divide by cos x, then 2 tan x. Yes or no?
Yes, sir.
Or this one also you can simplify. This one also, tan x you can write sin by cos, then you get same thing.
Yes, sir.
If they ask you to show, that's the thing. Otherwise, you can put any answer. Here sin 2x cos 2x dx by 9 minus cos or 4 2x. Okay, this is also important. Obviously,
Yes, sir.
if you see this, you will understand
The 3 square minus cos square 2x whole square.
cos square 2x is t. Why? Why? 2 cos x into cos 2x into cos 2x ka sin minus sin 2x into 2x ka 2 into dx is dt. That means numerator sin 2x
Yes.
it is minus 1 by 4 dt. And 9 minus t square over. So
Yes, sir. Then done only
t
problem.
square. This is what? Sin x
dt.
minus 4 goes that side. Dx is
Dx.
minus dt by 4. Yes or no?
Yes, sir.
That's it. Minus 1 by 4 into dt by root over 9 minus t square sin inverse t by 3. This is very, 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 very important. 43. I told you to do this now. Why you did not do?
I only did the exercise, not the examples.
43 and then 44, last question. Yeah, 44 is last. 43, 44, both are very, 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 very important. Sir discussed all these things in the school.
No, so we did a few examples from before the 7.11 exercise, but I don't, I think he discussed the 44th question, but not the 43rd question.
Minus 1 to 1 and then 1 to 1.5. 3 by 2 is 1.5. Okay, x sine pi x. So very interesting. Many students won't understand. Almost all the students won't understand this. Yes. Generally, you see, how do we discuss this? So sine pi x when you say sine pi x, are you ready?
Yes, sir.
When you say sine pi x, which quadrant is this? We don't know.
Yes, sir.
So now pi x now belongs to Q1, I think. 0 to pi by 2. I am checking in first quadrant. What happens to first quadrant? If it is in first quadrant, what happens? That's what is my question. So that means what? Pi x lies between 0 and pi by 2. Understand? That means 0 is
Yes, sir.
less than 1 by 2. Understand this? Yes or no?
Yes, sir.
X is positive, pi x is, so x is greater than 0, and sine pi x also, because it is first quadrant, na? Pi x is in the first 0 to pi by. Both are positive. So therefore, x sine pi x is positive. Okay, this is how you should decide. That's what I want to just, I want to show you this. Because now here it is written directly, how you understand? Yes or no?
Yes, sir.
So, but now we'll do it. Yeah, now you got this point?
Yes, sir.
Now you
So
see?
we just assumed pi x belongs to 0 to pi by 2, no?
No, yeah, obviously, no, this, yeah, this is no, -1 to no, see, otherwise you can take like this way. -1, okay, less than, you take x value, now -1 less than, x less than 1, 0. Let's take this. No problem.
Yes, sir.
-1 to 0 you can take. So then I want what? Pi x I want, na? X is negative. X is less than 0. Negative. Then sine pi x, what happens? That you have to see. Minus pi less than pi x less than 0. Which quadrant? Minus pi to 0, Minus pi to 0 is here. Which quadrant? Third and fourth. Q3.
Third and fourth.
4. Okay. Then what I want? Sine pi x I want. Now that sine pi x is what then? Sine pi x is less than 0. Yes or no? Third and
Yes, sir.
sine theta. Sine theta. This is theta, whatever it is. Sine theta is less than 0.
Less than 0.
Theta belongs to minus pi to 0. That is Q3 and
Third and fourth quadrant.
okay, this is less than 0. This is also less than 0. Therefore, x sine pi x is greater than 0. Yes or no? Greater than 0. If
Yes, sir.
x belongs to -1 to 0. Understand? First you got it.
Yes, sir.
-1 to 0 you got. Okay. Number 1. Number 2, I'll take x between 0 to 1 by 2. This only 0 to 1 by 2. Then why? Because pi x I want. Pi by 2, hai na? 0 to pi by 2. Okay, pi x belongs to 0 pi by 2 implies sine pi x is, this is theta, right? Theta belongs to 0 to pi by 2. Sine pi x is positive or negative?
Positive.
Okay, x is positive.
Yes, sir.
Sine pi x is positive. That implies what? X sine pi x is greater than 0. If x belongs to 0 to 1 by 2. And
Yes, sir.
1
First
to 0 you got, 0 to 1 by 2 you got. But actually, 0 to 1 also is the same thing. I need not check this. For your understanding, I checked. But here 1 by 2 less than x less than 1. Then pi by 2 say pi x is from pi by 2 to pi. Second quadrant is also is positive, Sine pi x is positive. Yes or no? Second
Yes, sir.
theta is positive, pi by 2 pi. Then also it's positive. X is positive, sine pi x is positive. Therefore, this what you can 1 by 2 to 1 also can write. That means what? X belongs to both 0 to 1. Okay, 0 to 1 it is positive.
Yes, sir.
First one is negative into negative, positive.
Yes, the second one is positive into positive. So that's
Positive.
positive.
That is the reason. Minus 1 to 1, it is completely positive. Minus 1 to 0 positive, 0 to 1 positive. If it is positive, write as it is. Na? Minus 1 to 1, x sine pi x you write as it is. Tx plus 1 to
Yes.
2, 1 to 3 by 2. Right? 1 to 3 by 2 now you can do. 1 to 3 by 2. Now 1 less than x less than 3 by 2. Which
3
quadrant?
by 2.
Pi less than pi x less than 3 pi by 2. Which quadrant?
So third and third quadrant.
Third quadrant sign is
Negative.
negative, x is positive, x sine x is negative.
Negative. Yes, sir.
Because x is positive. Okay. Sine x,
Yes, sir.
sine pi x. Now sine pi x is third quadrant negative. So x sine pi x is negative. You understand? Like
Yes, sir.
to do.
Yes, sir.
So now you see that's why minus 1 to 1 it is positive, right as it is. See, that's the reason. Minus 1 to 1, right as it is. But 1 to 3 by 2, it's already negative. So put one more negative. Minus x sine pi x.
Yes, sir.
Now if you integrate, then you take this uv. uv integration. Oh, ho, ho, ho. No, pi x is there, no? Yeah, uv only. Two functions are there. There's no transfer. Yeah.
So we apply UV, then we replace the values and we get the answer.
Obviously, no,
Yeah.
x, uv. You applied uv, you applied uv, na? SR
Yes, sir.
is u and this is v. You know, u into integration of v. That is sin pi x
So it's
cos pi x by pi.
supposed to be V into U, no?
By u into v, na? Algebraic, na? I late, na?
Okay. I was thinking in no. Yes, sir. Sorry.
Algebraic trigonometry, na?
Algebraic trigonometry.
Into
Yes, sir.
minus cos pi x, है ना? Pi x by pi.
Yes, sir.
As integration of x का 1. Again, minus
And then cos pi
pi x by
cos
pi. Again, the minus
whole dx.
x by pi cos pi x minus plus